So let's end this chapter and this course going back to the dynamics of what we have been learning, ocean and atmosphere, but we worried about their interactions in the context of climate at all time scales. So this is a nice figure again produced by Burke et al., which puts the paleoclimate time series we had looked at along with the projections at the end. Obviously, you have to be careful of the scale here. The x-axis has non-linear scale, so you have to be careful. Nonetheless, we had looked at this part of very warm Paleocene, Eocene with the Paleocene, Eocene thermal maximum. So there were southern hemisphere ice sheets here, northern hemisphere ice sheets over this whole period, and now we are putting some doubts on whether they will survive or not by the time we reach the next coming century and the next century. There is the early Eocene, mid-Pliocene, in the last interglacial warm temperatures, mid-Holocene, and pre-industrial historical climate change, and the future projections by combining various data sets and projections. Okay, this gives us a context that we were very warm in the past, but the main thing to remember is that we were not around back then. So by the time we arrived a few million years ago as our ancestors, we were already pretty close to where we are, just a few degrees away. And then we have vacillated from cold glacial to interglacial, and then we have warmed into the Holocene, which was fairly flat, where we became the modern human beings with our current lifestyles evolving just so fast. And the question is, where are we headed, and are we capable of surviving these kind of warmings, almost back to 60 million years, 55 to 60 million years ago. Okay, so this is a nice plot that puts our climate science or ocean atmosphere dynamics in context. This is the other nice paper that just came out in Science, I think, with lots of authors. You can look it up. It looks at, again, the CO2 and they call it the anthropogenic climate aberration. So if you look at the CO2 variability that we have been looking at from Vostok ice core and beyond, the Homo sapiens evolved around here with CO2 of around 280 or less, and the Industrial Revolution has kicked us into this steroid charged acceleration going beyond anything we have seen recently. So still keeping the context of where we were coming from and how we are kind of jumping out of the long-term cooling that we had talked about, and where we would end up if we went with business as usual with RCP. That would put us way beyond anything we have seen in the last 65 million years. So mid-Cretaceous was here, would be way, way beyond that. Early Eocene was here. So RCP 4.5 and 2.6 keep us more in a more realistic range. So the disappearance of the Antarctic ice sheet and Greenland ice sheet would occur once we hit these certain levels. So Greenland is already teetering because its melting is accelerating, and there are fascinating processes of why it's accelerating, which we didn't go into in great depth. This is the editorial summary of that paper, showing the scale of future climates. Sustainability versus middle of the road versus high emissions in the context of the last glacial maximum, pre-industrial, so going to 0.02 million years ago, back to 1750, year 1750, today, and where we are headed in the future. We will go past Eocene and mid-Cretaceous levels if we go into the high emission scenarios. Okay. The paper also puts the global temperature maps in the context. So this is the temperature, and this is the CO2. Here it is in ppm, and the various scenarios. So we talked about, I won't go into too many details, I just wanted to bring you back to the climate science side before ending it. So the temperatures were really warm during the hot house of the mid-Cretaceous. Early Eocene, the tropics cooled and the high latitudes cooled, and you can clearly see the polar amplification here as well. So the ice albedo feedbacks are not the cause, but you still have high latitude warming and the equator to pole temperature feedbacks, temperature gradient creating the climate response. Pliocene is much cooler, and here is the last glacial maximum, of course, was the coldest in recent times, before my throat gets dry. We have been talking about RCPs, the representative concentration pathways. Recently, something called shared social science pathways, socioeconomic pathways have been created, which include mitigation mitigation and adaptation options to create what are the choices societies will face based on the RCPs. So they have SSP1 at 2.6, SSP2 at 4.5, SSP5 because we skipped the SSP 6 point whatever. So this puts us in the range of CO2 that is shown here based on what choices we make in the coming years and decades. Okay, so this is a nice summary, and that's how I wanted to kind of end the course, to say that we have learned ocean and atmosphere dynamics because it allows us to figure out the climate sensitivities and the past climate scenarios that have occurred with changes in tectonics, changes in radiative forcing, changes in orbital forcing, which is of course radiative forcing as well, glacial interglacial cycles, and the main concept throughout has been that CO2 is always a player and internal feedbacks are always important. So we are now perturbing CO2 and other greenhouse gases and forests and oceans and land and everything else, urbanization. So now we are at a junction to decide what the future will be. How do you manage the system's evolution into the future with us making so many perturbations? So the dynamics is obviously critical foundation for doing many of these things, but also to remember that climate change issues and decisions are mostly socioeconomic decisions.